A quadratic equation can give us different types of roots. Either they could be distinct real roots, or no real roots, or equal real roots. Let's see some graphical representation of different types of root and how we actually identify whether if it's real, equal, or not real. The most important thing in this scenario is discriminant that come from the quadratic formula x equals to minus b plus minus root b square minus 4ac upon 2a. This b square minus 4ac, this is discriminant. This b square minus 4ac is called discriminant, and it decides if our equation will give us real roots or equal roots or no real roots. So let's draw some graphs of real roots, no real roots, and what are those conditions. Let's have a look. Alright, so first we are going to discuss about the real roots. If our discriminant has this value like p square minus 4ac, you substitute the value of a, b and c from the equation, and if you find your answer which is greater than 0, then it means that this equation will give you two distinct real roots, and definitely you would have two intercept, x-intercept that you could see here, that is alpha and the beta. There is a kind of difference between these two graphs because in the first one, if you see over here, a is greater than 0. If a is greater than 0, then the equation will have the graph facing upward, or you could call it happy face. And if you have an equation in which the value of a is less than 0, it means minus 1, minus 2, minus 3, or so on. It doesn't matter, but if that thing is like less than 0, then this graph will be facing downward, and definitely it's a set face. This graph, the graph which is facing upward, it will give you minimum value, and this graph which is facing downward will definitely give you maximum values. Now move on to the next category of roots, which is equal real roots. Alright, so in this category we'll see what are equal real roots. If our discriminant, that is b square minus 4ac, is equals to 0, then we have equal real roots, and line or the x-axis is tangent to the curve. If you could just look at the figure, you'll find this shows like a is greater than 0, but if you just concentrate over here, this curve or the parabola is touching the x-axis and it's tangent over it. So this is the condition whenever you've been asked about equal real roots, and if they have given you any sort of condition in which you have to find the equal real roots, so you just have to put your discriminant equals to 0, and this is the most tested question you will find in the exam, and you will often come across with it. So now move on to the next category, in which we have no real roots. In this, we'll see b square minus 4ac is less than 0. So no real roots, no x-intercept, and y equals to ax square plus bx plus c is either always positive or always negative. Alright, so in this one, if you have your discriminant which is b square minus 4ac, and if it is less than 0, so you will have no real roots. As you could see here, this curve is not cutting x-axis, so it's not giving you any x values in it. In this scenario, this is a greater than 0 and this a is less than 0. So the equation ax squared plus bx plus c is equals to 0. In this case, in both the cases, either it would be positive, always positive, or it will always be negative. So you need to keep that in mind. No real roots, no x-intercept. This is the condition for no real roots. Let's take some equation to further solidify our concept. How do we actually check it if some equation is giving us equal real roots or distinct real roots or whatever type of root we are getting? Let's see. We have an equation x squared plus 4x plus 4. Right, in this equation we have a is equals to 1, b is equals to 4, and c is equals to 4. Let's apply the discriminant in it. B square minus 4ac. So 4 square minus 4, 1 in the c. So 16 minus 16 is equals to 0. It means that this equation will give you equal real roots. Let's check another equation. We have a is equals to 1, b is equals to minus 2, c equals to minus 1. The formula for the discriminant is b square minus 4ac. So minus 2 square minus 4, 1, minus 1, 4 plus 4. And this is 8, which is greater than 0. So it means that this equation is going to give you two distinct real roots.